So last week, we have finally made it so many weeks into the AI learning. And just last week, I was going through some articles and I had some interesting topics that I discovered, and I thought I will just present it to you. By now, by 93 days, you have been exposed to, immersed in a lot of different topics. And I'm sure everybody has a basic grasp and understanding of why we are doing this, what we are learning, what are the different types, and all those things. Each may be in different, part of the graph learning, but at least we have all been exposed. In that way, I'm really happy. And this particular topic, I found it a little bit more higher order, but still it is very essential for anybody deeply interested in machine learning concepts. Okay, so the I just learned there is 5 tribes of machine learning, and I also learned that there are different use cases for machine learning. So that's what I'm going to show it to you today. So the different ML tribes, the people, the groups or cohorts of people from a usage standpoint. A business person with a general interest, you can say somebody wants to make use of AI, but he's not technical. He's just a business person. He has a lot of capital and he wants to do so. That person falls under the business tribe. The second is a manager interested in delivering a project. There are a lot of product managers in Amazon or other companies, large companies, and their goal is a particular business function. How can I deliver that with the help of machine learning and things like that? That's the second type of person who wants to use machine learning to do something. Okay, those are business tribes. Then coming to the academic tribes, you have ML student in an undergrad or a graduate class. I was 120 years ago. We were doing ML programs for face recognition. So people of that category who want to use a small portion of the ML to achieve something. And then the next stage in that is a researcher in a company who wants to use a particular model or a machine learning algorithm to develop a niche product like a blood monitor or something like that. Those people fall into the fourth category. And then fifth is a general researcher interested in modeling their problem. So all these days, we have heard a lot about large language models, LLMs. That is, GPT is a LLM, and there are a lot of LLMs, Palm and Bard and other things are there. So a researcher interested in modeling their problem, that those people fall under the academic tribes. And when it comes to engineering tribes, just like you and me, a programmer interested in implementing an algorithm. I know teams who are implementing certain algorithms to achieve a business functionality. Where is that machine learning package available that I can ready-made use and try to implement this? So those people come under the sixth type. And seventh type, again, developer interested in delivering one-off predictions. Whether this email is a spam or is it a good email. Developer wants to create a product for just one-off predictions. Those people fall under the seventh category. And then engineer interested in developing smarter software and services. So a lot of us, we are now exposed to Code Whisperer or Copilot or things like that. We want to write smart software and services with the help of these AI tools. So we again fall under the eighth category over here. And there are people like the data scientists in our company who all this time they were writing SQL queries to find answers to business questions, but now they can apply some kind of machine learning model that actually gets you better answers, makes better connections with all the rich data. So that is another type. And then data analysts interested in better explaining data, like what caused this? What is the correlation between this event and what caused this? So instead of a human being thinking and trying to make relevances, the machine would actually try to say, this is why you had 2 billion extra sales in this thing. So those people, data analysts, can also use ML for their purpose. So this is a different standpoint. This is from a usage standpoint. Who all wants to have a pie, have a small go at the ML world. So I found that interesting, and I thought I'll bring it to you so you can have it in your mind. Am I falling under one or two or more than two categories here? Then I need to act in a different way, something like that. You can deduce something from that. The second thing is the URL that I gave you maybe a week ago when I saw that first. It was a TED talk by Pedro Domingos, who wrote this book, The Master Algorithm, How the Quest for the Ultimate machine learning machine will remake our world. So his TEDx talk was very informative, very insightful, and he has made other YouTube videos also. So when I watched that, I thought we will bring this and just open it out to you so you can also think about it. So he says we have been doing A and NI, artificial narrow intelligence, one algorithm to solve one problem, right? So the next step is AGI, which is general intelligence, which will be able to think and do anything, not just a specific narrowed down, a wide range of tasks, both trivial and complex tasks. And that's where he introduces that there are different cohorts or group of key people thinking there is different ways to achieve artificial general intelligence, and that is very interesting. So I say that you have to go from Trichy to Chennai in GST. Somebody says no, you have to go through ECR. Somebody says you have to go through Coimbatore. So there are different school of thoughts, and everybody is holding on to this is the right road to get there. So let's see this interesting pattern. So the 5 tribes generally in the market are symbolists, Bayesians, connectionists, evolutionaries, and analyzers. Analogizers. Yeah. So these 5 types of people are there. Everybody have their own theory of how we can reach artificial general intelligence. Okay. The first group of people, they use symbols, rules, and logic to represent knowledge and draw logical inference. And the algorithms they think will eventually become the master algorithm is the decision tree algorithm. So in the past 90 days, we would have seen unsupervised learning, supervised learning, and then this deep learning and things like that. And under all those types, you would have seen all these different algorithms, convolutional neural network, recurrent neural network, all those things, right? So some of these algorithms fall under these different tribes. So it's good to know that, okay? So the second is Bayesians, third is connectionists. So we will dig a little bit deeper into knowing who are those people and how they think in that angle, okay? So the first group of people is symbolists. So the famous symbolist is, again, I picked all this information from his YouTube, so it was pretty easy for me. Tom Michel, Steve Muggleton, Ross Quinlan, these are top people in AI in the symbolist group. Okay, so the principle they talk about is inverse deduction. That is, given all the facts, you can deduce the rules from it, and from that you can once you have the rules again, now you can come up with facts, right? So one thing that it said was like, if say Julius Caesar is human, and then all humans are mortal, then the rule is Julius Caesar is mortal. He's not immortal. So if there is any part of that thing is missing, you can actually do the inverse deduction and find what it is. So that's what they're saying, symbolism. Like based on one thing, you can arrive at another. Okay, subtraction is the inverse of addition. Differentiation is the inverse of integration. So they are going in that particular angle to achieve the artificial general intelligence. And it is said that it is mostly favored by scientists for filling gaps in understanding, because they start with a problem statement and they don't know how to solve it, but they know there are some steps in the middle and this is the end result. So they use symbolism to actually fill those gaps and try to arrive at a solution for a problem. And also I was learning something about inferences made by chaining the rules. So it's getting complex, but I think it's enough if we understand the definition. What is a symbolist? Why they think this approach will lead to the general intelligence. Okay, so can anybody take a wild guess? Who is the biologist in this picture? Anyone? This man or that man?
One at the back.
One at the back. Okay. I was also fooled, Kavita. So the biologist in the picture is that machine that you are seeing behind you. So that's the machine is called Adam, and it uses symbolism to arrive at this is the solution that they want. So let me try to fill the gaps. So it has a DNA sequencer, it has a all the centrifugal, all kind of biological equipments connected. It arrives at the experimentation. It tries out the experimentation, and it has recently discovered a drug for malaria. One machine has discovered the drug by just deducing. So the possibilities are endless. The different healthcare systems, healthcare health deficiencies, that the drugs can be found by just separate machines running on its own, trying to arrive at this is the solution. I want a solution which will cure this, disease or something like that. So that's what they say is symbolism is. Okay. And the second type of people are connectionists. So basically, they believe that connections is what will lead to that master algorithm. So the center person only recently I came to know because he resigned from Google, Jeffrey Hinton, and he is touted to be the father of backpropagation. Backpropagation is a concept in neural networks. So neural networks is very much modeled based on our brain, how our brain works. It has many neurons, and there is information coming from one side. There is decisions being made on the other side. So all these connections is what makes that learning and that intelligence. So that is why they are named as connectionists. These are the top people in the connectionist camp, you might say. So how they are saying is a neuron in a brain is basically a cell with a cell body and then a long axon, and on the end you have dendrites. The dendrites again connected to further neurons. So there is a dense network of neurons. One neuron will pass some information to the next neuron, and each neuron will have a threshold. Only if the current value, electric impulse crosses that, then the neuron will be fired and it will send a message. So there is like 10 neurons. Some neurons might fire, some neurons might not fire. And based on that, the brain will make a separate decision. And when the alternate happens, it will take a different decision. So that's how the neuron works. So based on that, the neural network algorithm is also working. You have some inputs. It could be a 256 by 256 image of a cat. You take each of those pixels, a very large number. You align them up as inputs. Then you have several, layers of neurons. And finally, you have an output, whether it's a cat or a dog or a crow. And then it just takes different parts. It lights up certain neurons. And finally, you have the answer. This is a cat. This is a picture of a cat or a mouse. So that is very much all the connections that is in your brain mimicking that. So this is the camp of the connectionist. So you most of you know about neural networks, but this was a new thing that they belong to a group called connectionists. The third is evolutionaries. Evolutionaries, they speak of a logic where, okay, brain, you took a brain and then you said brain works this way. So the general algorithm should, intelligence should work this way. But how did the brain even come into place? That was through evolution. So they think evolution is the way the master algorithm can be achieved. So their programs are called genetic algorithms. They allow for mutation of a particular point, and then they evaluate the fitness, whether the algorithm has reached no, then they mutate something else. So over the next generation, you will be making smarter decisions. So we can assume that our very old generations had limited, faculties, and we have, evolved to have more faculties. So that's the concept of evolutionaries. Okay. And they have applied this logic to robots, where just like a human body, you have an elbow. Your elbow can only go front, but you can't bend it backwards, both your knee. So you have some certain degrees of freedom, right? And robot also has, if it has a leg that cannot go up, that's the degree of freedom. So it makes some mistakes, and then every generation it learns, okay, this is how I need to climb, this is how I need to walk, this is how I need to crawl. So this genetic algorithm is applied for this kind of learning purposes, where the robots experience the environment and then they learn on their own. Okay. And recently I also I was taken to this particular thing. You see, DeepMinds is teaching itself Parker. So the stick figure knows what are its degree of motion. Are you able to see the moving animation? Okay. So it knows that it has a body, it has a femur, it has a knee, it has a shin and leg. So it can't bend the knee bone on the other side. It can only bend. So based on that rules, it is evolving slowly, and it knows how to quickly cross the hurdles and everything. So upon multiple generations. So that's why this is evolutionary approach of AI is applied to certain things, and that can be maybe easily transferred to a robot. So a robot knows how to cross, how to scale a wall, how to jump a puddle, all those things, right? So that's about it. So, and then the fourth type is Bayesians. You might have been introduced to the Bayes theorem. Bayes theorem is a statistical model. So this group of people you see here, David Heckerman, Julia Pearl, Michael Jordan, they think statistical approach will only lead to artificial general intelligence. So they are the most fanatical terrorist kind of people because they think no other approach will work, only Bayesian approach will work. And Bayesian approach is just the probability of something A happening given B happening is equal to the probability of B happening given A into the probability of A divided by probability of B. This is a very simple Bayes theorem, but based on this, several machine learning algorithms are using these concepts, underlying concepts. So the Bayesianists are just a group of people who think this is the master algorithm which will lead to that general intelligence, something like that. So that's again another group. The final group is analogizers. So what they do is everything we do in the world is through analogy. So we learn one thing and we apply it in another thing. So these group of people think analogizers and any ML which does analogy is the only one which will reach the top AGI level. So they think support vector machines are the best algorithms to reach that general intelligence because support vector machines, when you have a plot of data, it will try to accurately give you a decision boundary which will separate the two classes. Okay, if you draw a boundary, to the left is one class, to the right is another class. It will easily do classification. So this group of people, and the Peter Hart is a very prominent person. He has written several books. So this is the fifth group of people. Okay, so I just wanted to bring this concept of this five people. The five people are symbolists. They do structural inference, and they do rule-based systems and all those things. The connectionists are the brain people. They think neural network and connections are the true way to achieve the AGI. The third people, the Bayesianists, are the statistical people. Based on probability and statistical evidence, we can arrive at the general intelligence. The evolutionaries are structured learning. Make some changes, allow it. Is it surviving? Is it failing? Okay, now make changes. Give it many generations of evolution, it will evolve. So that is the fourth group. And the fifth group is analogizers. They map it to novelty, and K nearest neighbors and support vector machines are some of the machine learning algorithms that falls under that tribe. Okay, so those are the five tribes I learned, and I thought it'll be interesting for you to also look into it. Okay, thank you.